All right, let's just get right into it. If you've ever tried to run a modern application locally, you know the deal, right? It's never just one thing. You've got your API, you've got your database, maybe a front end. And trying to spin all that up with separate Docker run commands, it feels like you're juggling chainsaws. It's just this mess of super long commands, manual networking, and honestly, a ton of frustration. So what if we could tame all that chaos with just one single file and one simple command? Well, that's exactly what Docker Compose is all about, and that's what we're going to break down right now.
I mean, just look at this. You can feel the difference, can't you? On the left, that's the old way. It's a total nightmare. You're copy-pasting these huge, complex commands, praying you get them in the right order. It's just so easy to mess up. But then, you look over on the right. Ah, the Compose way. One single command, Docker Compose up. That's it. Your entire application, all its parts, just springs to life. It is literally the difference between chaos and control.
So yeah, it totally feels like magic, doesn't it? How on earth does one file and one command replace all that manual mess? Well, it's not magic, but it's pretty close. It's all about having a really, really smart blueprint. And now, we're going to peek inside that blueprint, the Docker Compose.yml file, and figure out exactly how it pulls this off.
Okay, so the very first thing we need to understand in our blueprint is this idea of services. It's simple, really. A service is just one piece of your application's puzzle. You know, like your API is one service and your database is another service. Each one runs in its own container.
Now, here's where it gets interesting. How do we tell Compose where to get these services? Well, we have two main ways. For our own custom code, like our API, we use build ... That's us telling Compose, hey, the code is right here. Look for the Docker file in this folder and build it from scratch. But for something common like our database, we use image Postgres. This is a game changer. We're basically saying, don't bother building this. Just go grab the official ready-made Postgres image from Docker Hub. Talk about a time saver. Why reinvent the wheel, right?
All right, so we've got our services defined. We're feeling good. But we've just run smack into our first big, hairy problem. I like to call it data amnesia. And trust me, when it comes to your database, this is the stuff of nightmares.
So here's the deal. By design, Docker containers are, well, they're ephemeral. It's just a fancy way of saying they're temporary. So any data that gets created inside a container's file system, think about all your precious user accounts in the database, it's just gone. The second you stop and remove that container, poof, vanished forever. This is obviously a huge problem. So how do we fix it? How do we give our database a permanent memory?
Thankfully, the solution is super elegant. It's a feature called volumes, and it's a simple two-step process right inside our Compose file. First, at the very top level of the file, we just declare a named volume. You can think of this like creating a little virtual hard drive that exists completely outside our containers. Then, for step 2, we go into our database service and we tell it to attach that volume or mount it to the exact folder inside the container where Postgres keeps all its data. It's kind of like plugging an external hard drive directly into our database.
And boom, just like that, problem solved. Your data is now safe. Because now, whenever your database writes something, it's not writing it inside the temporary container. It's writing it to that permanent external volume. So you can stop, remove, and recreate that container 100 times, and every single time, it'll just reconnect to that same volume, and all your data will be right there, waiting. Data amnesia is cured.
Okay, one problem down. Our data is safe. Awesome. But we've got a new issue. Our API and our database, they're giving each other the silent treatment. They're sitting right next to each other, but they absolutely cannot talk.
And why is that? Well, it's actually a security feature. By default, Docker puts every container in its own little isolated bubble. Think of it like putting your API and your database in separate, soundproofed, quarantined rooms. The API can be screaming its head off trying to connect to the database, but it won't hear a thing. They're just totally cut off from each other.
So how do we get them talking? Well, the solution is going to look really familiar. It's almost the same pattern as volumes. First, in our top-level configuration, we create a new custom network. We can name it anything we like. Then, and this is the key part, we go into both the API service and the database service, and we tell each of them to connect to that very same network.
And there you have it. The silent treatment is over. By putting them on the same shared network, we've basically just built a private hallway between their two isolated rooms so they can finally communicate. And here's a really cool bonus.
Once they're on the same network, your API can find the database just by using its service name, Postgres-DB. No more digging around for confusing IP addresses. It's super clean.
Okay, deep breaths. We've got permanent data, we've got networking, we are so close. But there is one last sneaky but absolutely critical problem we have to solve. It's called a race condition. Think about it. What happens if our API boots up super fast and tries to connect to the database, but the database is still in the middle of its own startup routine? Yeah, our app crashes.
I mean, it seems like a trick question, right? It's completely obvious. Of course, the database needs to be ready to go before the app tries to connect to it. The problem is, by default, Docker Compose doesn't actually care. It might start them both at the same time, or even start the app first. It's just a free-for-all.
So how do we fix this? How do we force an order? Well, you're going to love this. It's this one simple, beautiful line. That's it. Inside our API's service definition, we just add depends on and tell it about the database service. This is our crystal clear instruction to Compose that says, hey, do not, under any circumstances, start this API until you see that the PostgreSDB container is up and running. And just like that, the race condition is gone.
All right, let's just take a step back and look at what we did. We defined our services, we used volumes to make our data permanent, we used networks so they can talk to each other, and we used depends on to make sure they start in the right order. All that work in our blueprint file brings us right back to that beautiful, simple promise we started with.
This right here, this is the whole payoff. After setting up that one clean, readable configuration file, this is all you ever need to type. Docker Compose up. That little D flag at the end, that just tells it to run everything in the background so you get your terminal back. You hit enter on this one command, and Docker Compose reads your entire blueprint and brings your whole application to life perfectly every single time. And that, my friends, is the magic of Docker Compose. We literally went from total container chaos to having complete control. We've got one single file that defines everything. We've got permanent data with volumes, we've got easy communication with networks, a reliable startup order with depends on, and probably the best part, we now have a totally portable, one-command development environment. Any developer on your team can just grab the code, run that one command, and have the exact same setup running in minutes.
So you see, by taking our application's architecture and just describing it in this simple blueprint, we've made it reliable, portable, and just so much easier to manage. So really, the only question left for you is, what complicated, messy application are you going to simplify next?